Hello guys, welcome back to a new video. So in today's video, we are gonna discuss the subject BEC602, that is, on a second, BEC602 VLSI design. So I have made the analysis based on the three papers currently. One is the paper which we attended, means I attended, and the remaining two are the some previous years and one model paper. So you can see all this are available on my in description notes. You can easily refer, so no need to screenshot this. And at the last I have attached the questions from where which I have taken. This is the our paper which we attempted. Then these are the some previous years. So let's begin to the video. So here comes the first question. What is the comparison between CMOS and NMOS? This usually carries 5 marks. Sometime it goes to the 10 marks, so you should be careful. You can skip these all steps, but 5 marks means 5 points. You should be writing 1 marks for each point. So easily you can write 5 to 6 7 points. This is also a confirmed question. Then at second, physical representation of transmission gates with a neat diagram. So here it is 5 marks means in this subject there is no need to write theory much, but you should be careful that you should be drawing the diagrams correctly and naming it input, output, what is the good, what is the bad outputs. You should be remembering it. So these two questions are there. These are also fixed, but in this there is a twist. Like the equations may come variably. Like sometimes a dot product, sometimes there will be a line on it. So we can't predict which equations may come to simplify, but it will be easy one. If it is like something this one, I will be making a separate video on how to solve this. So currently we will be skipping this, but these are also a fixed question. 10 marks easily we can score just by drawing the diagrams and simplifying the equation. Next comes the deep flip-flop using transmission gates with the necessary. Here also the diagram and truth table, like what is the LD is equal to 1 and a hold mode what it is. Then comes the question number 6, representation. Here the question arises like this is a very lengthy answer for this behavior, structure, physical. I have mentioned a full answer, but still you should be remembering that it is asked for the 6 marks. Then it will be 2, 2, 2. So it is better to write the definition about it and one example about it. Like easily you can be scoring it. If you are including the equations, then it is well and good. Then this is the full answer about it. Then comes the physical representation. This is an important question. Remember it, because inverter is most frequently asked, and module 1 is fully dependent upon the inverter and the different types of gate, NAND, NOR. You should be remembering it. So easily you can draw, but remember naming them correctly, like polysilicon, metal, out metal, in transistor. You should be different. That examiner should differentiate between what is a polysilicon, what it is like metal. He can easily differentiate. On basis of that you should be drawing that. And main important is again table, what is the table says. Then comes the tri-state inverter. As I told, inverter is most important. In tri-state, how, what is the enable? At enable 0 what happens, at enable 1 what happens. As the subject contains more diagrams, you should be more focusing on the diagrams rather than theory. And symbol also sometimes it may carry marks and sometimes not. And next is multiplexer, how a 2 is to 2 in 2 is to 1 multiplexer using tri-state inverter. Then again diagrams, truth table also is important here. In this question it is 8 marks, means you can easily calculate 2 marks for a diagram, 3 marks for truth table, or 4 marks for truth table and 2 marks for a diagram, and rest. And here also 1 marks for the equation. You can easily split up how based on that. But here comes the again one twist. This is also a common question, basic question, like what is the operation, the diagrams. As it is near to 10 marks, you should be drawing the diagrams. And anyone you can draw, P or N, anyone you can draw, but it is mandatory to draw the symbols of the both. So you can easily differentiate which is the N1 and which is the P1. And here is the operation. What are the drain, source, positive voltage NMOS, for negative voltage for PMOS, what is the control terminal, how we should be controlling it. You can easily explain it. Now comes the part 2 of this module, where is main is like you should be deriving. First one is the linear equation. One thing you should be remembering, either it is for drain current, NMOS or PMOS. Anyone they can ask, but the derivation remains same. So you should be taking these equations, linear regions, then assuming this. This is also a lengthy equation, but here it is one trick. What is like you can skip some theory, you can directly write the equations and mark them in the box. As this is for 8 marks, you can easily write the equations, but remember, put them in directly box so that examiner gets easily highlighted that this is the equation, so this boy has been, girl has been did the correctly steps. Means don't jump directly to final equation for this. Here it is. Don't jump for this directly, as it is 8 marks. Still, to be on safer side, write all 11 equations. So easily 1 1 1 1 1 1 you can write it. This derivation also is easy. If you want, I can make a separate video on it explaining how the equation is derived. If you want, then comment on it. Then comes again on saturation region. This is also easy. If you learned this derivation, then this will be automatically easy because you are substituting directly values here in this equation. Again comes this final, but here comes the main twist is it is best to write all the summary of the equation, like at cutoff stage what is the equation, at linear what is, and saturation what is, beta by 2 this. It is better to write all rather than losing marks here. Then comes again inverter DC transfer characteristics. Here diagrams carry a main marks, how the current will be going VDD and how it will be going down, as I have explained here. Here also equations. Main thing is like for NMOS it is positive, for PMOS it is negative. Then comes their graph. Their graph plays an important role. Based on graph only, you are going to define which is the operation region and which is the saturation region and which is the linear region. This plays an important role, so don't forget about this. Even if you write 2 lines less theory, but don't forget to draw the diagrams, as this subject is mostly dependent on the diagrams. So next comes the channel length modulation. Here I can say I have near to 9 definitions, some different. In one that channel length modulation is asked. So it is better to read all 9 definition, as I will be including in the notes. So this is the graph, and then they asked it. And here is the diagram. Again same definition diagram. Based on diagram only you can write. Depends upon the theory. If it is asked for less marks, then you can go for less theory. If it is for more marks, then it is to be on safer side. You should be writing all the theory. Then comes, as I said, again on definition is asked, but it is for 4 marks. Then you can easily write directly formula, a small diagram like, and a 2-3 lines explanation what channel length is there, what is VGS, and what it is doing currently. These are the definitions again for non-ideal heavy characteristics. What is temperature dependency, what is tunneling effect, what is subthreshold conduction, body effect, velocity saturation, mobility degradation. As some have derivations and some are not. Here it is as operation, how the NMOS, either it is NMOS or PMOS. Still, what are the IV characteristics? These are the 3 derivations. This is not a, but this and these are the derivations as I told up in the above section. So this is all. In this year they asked physical representation and alternate circuit representation, D flip-flop using transmission gates. As I told, here is the fixed question, as this is for 10 marks. Sometimes alone can come for 5 marks or 4 marks. If you are lucky, then the alone can go for 10 marks easily. But if it is 10 marks, then there will be a certain twist like this. As this comes near to XOR, I think. XOR, I don't remember. So this all I took the references of the question papers, how the question may ask. I can easily say, if you are doing this module, this is the passing module for VLSI. Again are there in front modules. In module 3 there is directly theory module. Still, this is an easy module. You can easily score 20 if you are doing these questions then. So be smart, study smart. If you need anything extra, then please comment down in the video. I will work on it. Thank you. Best of luck.